right, hello Aiden. We're starting 2-5. We're going to take 2 days to do this section because 3D figures, there's just lots of formulas. And so we'll do half today, half tomorrow. They start us off with 3D figures talking about polyhedrons is the first word. I'm going to circle that one. Polyhedron. Do you remember the other day when we talked about polygons?
Yes.
Like polygon. Okay, what does a polygon have to have? Or what is a polygon? What is polygon was not a polygon?
A closed three-dimensional figure made up of...
That's a polyhedron. What's a polygon?
Oh.
What is not a polygon? Do you remember what shape?
Circle.
A circle. Why is a circle not a polygon?
No straight lines.
Because it has to have straight lines. So polygon has straight lines.
At least.
Yep, at least 3 straight lines. If it doesn't have 3, why can't it just have 2? It won't close, right? Okay, so at least 3 straight lines. I'm just going to say straight lines, so a circle is not a polygon. All right, now, in the same way a circle is not a polygon, polyhedrons kind of go the same route, but polyhedrons are 3D figures, okay? So there are 5 of them, 5 3D figures that we're going to talk about. The first one is a prism. The second one is a pyramid, okay? Prisms and pyramids, a lot of people get them confused. A prism will have 2 bases, like a lid and a base, like a top and a bottom, right? A pyramid will only have one, it will come to a tip, okay? Now this is hard for kids to see if it's like setting on its side, right? Sometimes they'll look at it and like think that it's a pyramid or think that it's a prism if it's setting sideways, and it'll be kind of like hard to see, okay? So it comes to a tip versus it has 2 bases that are parallel to each other. All right, these are polyhedrons. These 3 are not polyhedrons. They are curved. This is a cylinder, a cone, and a sphere. Do you guys know those objects? Okay, Aiden, you're not going to be able to see this, but I'm going to go through this box with you guys. So Aiden, you can skip ahead a little bit. This box, I have all my shapes in here. We're going to name these shapes. All right, here we go. What is this thing? See, this is the one where it gets confusing. Is it a pyramid?
No.
It's a triangular prism because it has to set like this. You see that?
Yep.
That's where it gets confusing. It looks like it comes to a tip, but not one tip, right? Like this is a tent, and that's a triangular prism. So if I set it up right, the 2 triangles are the bases, okay? And triangular prism. All right, so that's a little confusing. This is a cone. This is a... Now, they will start to specify what kind of pyramid.
A square base.
It is a square pyramid or a rectangular pyramid, even though it's a square. So something of that nature, they'll call it a square pyramid, okay? We could have bases like of a pyramid that are like pentagons, right? So like a pentagonal pyramid is gonna have 5 of them up the side, okay? What is this? A cube, also called a rectangular prism, right? A square prism, okay? So that's what he looks like. What is this one? That's a rectangular prism, okay, because it's not a perfect cube. All right. What about this one? Okay, he's a prism, but what kind?
Octagon.
That's an octagon, I think. There's 8 sides. Okay, this is an octagonal prism. Got it? Okay. What about this one?
I can't see.
Cylinder.
Cylinder. It's hard to see with it. What about this one? Prism.
Prism.
Hexagon. Hexagonal prism. Okay.
Prism.
All right. What is
Prison.
prism? What is this?
Cylinder.
I pulled this out this morning and they were really confused.
Did they
Just
say
how
a
the
circle?
like how it's. Learned those in 2nd grade?
Yeah, I probably learned
Okay.
that in first grade.
Oh, you think so? All right. So here are some of those shapes that we just went over: a triangular prism, rectangular prism, all those good stuff. Okay. Here's a picture of the pentagonal pyramid that I didn't have. Right. Okay. So I don't have some of these shapes now. They also, I didn't talk about this first period, but they have a right prism. We're only going to be dealing with right prisms, but this is called an oblique prism. That's like a leaning thing, right? Where he's not 90-degree angles, okay? So you can have prisms that are oblique prisms. They're just kind of leaning to one side, whatever. We will only deal with right prisms today, okay? All right, here we go. These ones are kind of fun. These are Platonic solids is what they're called. This tetrahedron, how many sides does that tetrahedron have?
1, 2, 3, 4.
4. And, so tetra means 4, or like the prefix of it. Tetra means 4. Hedron It means like a three-dimensional figure, but these are made from equilateral triangles. Do you know what an equilateral triangle is?
Triangle where all the angles.
All the sides and all the angles are the same. So another way of saying that is a regular polyhedron, a regular polygon. So all of the sides and all the angles are the same. Okay, that's a tetrahedron. All right, a cube is also called a hexahedron because it's 6 of them. It's 6 squares that have all the same sides and all the same angles, right? Okay, an octahedron is just 2 tetrahedrons on top of each other. So I've taken this guy and I've slapped another one on the bottom, and he is an octahedron. It's like a diamond, like an actual diamond, three-dimensional diamond. You know, like one of those. Okay, that's an octahedron. Okay, this one is called a dodecahedron. What are his base shapes? Regular pentagons. Okay, so 5 sides that are all the same, pentagons. And there are how many pentagons shoved together? 12. Kind of like resembles maybe-ish a soccer ball if you need to think about it. Not quite the same, but like that's what you can maybe think of, okay, a soccer ball. Okay? And this last one is an icosahedron. He has 20 equilateral triangles that fit together, and he makes like another little ball shape, okay?
Can I say something cool about that one? That one is what viruses are made out of.
Really?
Yeah.
An icosahedron is a virus? Hey, that's kind of fun.
Search up bacteriophage on your computer.
What?
Or your phone. Do it if you want.
Their phones are up there because they're good people. They're good kids.
So that's gonna make me sick.
No. Bacteriophage kills bacteria, not you.
Kills bacteria?
Humans are immune to bacteriophage.
I wish I was a
You're
bacteria.
too big. They can't eat you.
Well, I'm gonna
Okay.
whatever one kills me.
Interesting. Interesting.
Is like the modern penicillin. Look.
If I'm a bacteria, give me the vaccine.
Okay.
Kill me.
So it's like a medicine.
That is gonna
Basically.
save your life one day.
No, it's like a robot.
It is kind of like a robot, but it's a
Bacteriophage.
functional virus, basically.
Interesting.
And they want to inject people with them to save their lives.
Well, it's basically like taking amoxicillin or
I
penicillin,
don't know, I
if
don't
that's
know.
what it is. Whatever. Anyway, all right. Moving on. Example 1. Here we go.
The correlation between that
This
and
one.
whatever the heck.
Whew, this is going to be kind of a little bit of a long example, and you're going to moan and groan for the second part, but I'm going to make it easier on you. Okay? Are we ready? This is an, we're going to name it here in a second. Okay? Identify the solid. If it's a polyhedron, name the bases, faces, edges, vertices. The solid is formed by polygonal faces, so it is a what? It is a polyhedron. This is a polyhedron. There is no base, right? It has no base that it sits on, okay? But the solid has how many triangular faces?
He basically almost
Shh.
failed.
Luke, hush.
8.
8 triangular faces. So he is a what?
He is an
Octahedron. Octahedron from above. He is an octahedron. So he's a polyhedron. He's an octahedron. He's kind of a special one. All right, here's the deal. Do you understand that he has no base? Right? Even if we like lay him down on one side, that's not considered a base, right? If we lump off the bottom half and just have the pyramid on top, yes, he will have a base, right? But this one will not, okay? So bases, there are none. They want us to name the faces. Okay, like one of the faces would be this front side, which is SQT, right? SQT. How many are there total? Faces. How many faces are there total? You get out of here, Luke. Go back to where you hail from. Where do you hail from this period?
I have no idea.
You don't know where you go 5th period?
Technically, I'm supposed to be in Cleaver's office, but
Okay, go there.
But she's in a meeting.
We don't care.
I'll be quiet.
Okay, be quiet. All right. So let's name the other faces. All 7 of them. All the rest of the 7 of them. Okay. What? Okay, I'm gonna go around the top. So this is this guy. Let's go TQU. It doesn't matter. You kind of have to have a system though, so otherwise you forget them. Okay. The back side is URQ. I don't care how you name them. It doesn't matter what order you go in. URQ. Okay. And then the left side. QRS. QRS. Okay, that's that side. Now we're gonna do the bottoms. Okay. The front side of the bottom, STV. Let me do that one. Okay. The right side. TUV. Do you see what I'm doing? What's the back side of the bottom?
RUV.
That's fine. That's fine. It doesn't matter what order you put them in. RUV. And then on the left side, SRV.
SUV.
Radius.
Wait.
Okay.
Hold on.
All right, edges. Do you know what an edge is?
Yeah.
An edge is like this guy. QT is one edge. How many edges are there total?
A lot.
A lot. 12. There's 4 around the top, 4 around the bottom, and 4 around like the middle. Okay? So QT is 1. Then we've got QU. Then what else? QR. QS. ST in the middle. TU. UR. RS. Around the bottom. SV. TV. UV. RV. That was 12 total. Okay? All right, vertices. How many vertices are there total?
QSTUR.
4, 5,
6. We just list them. Q and U and T and R and S and V. However you want to label them in that in whatever order. Okay? There are 6 of those. What a dang mess. Woo!
Can you move your screen down a little bit?
Please.
My screen. Oh, yeah. Let me get him to go away. There you go. Thank you. Okay, got it? I'm gonna go up. We have this other solid. It says this solid has curved surfaces, so it blank a polyhedron.
Is not.
Is not a polyhedron. Okay? It has 2 congruent and parallel circular bases, so it is a cylinder. Guess what? When it is not a polyhedron, we don't have to name the bases, faces, edges, and vertices. Woo! Very nice. Okay, good? Very nice. All right, go down to example 2, the next page. Okay? All right, identify the 3-dimensional figure that can model the beverage container and state whether it is a polyhedron or not. What is this container? Maybe. Not completely. Yeah, I think they're going with cylinder. Even though the top comes like a little bit higher and it's not a complete cylinder, that's probably what they're going with. Because the model has curved surfaces, it blank a polyhedron. Is not. It is not a polyhedron.
They could have chosen a way better picture.
I know.
They could have chosen
They could have chosen a soup can or, you know, like one like that. Yeah, that's like closer to a cylinder, right? Okay, good? Happy with that? All right, now we have surface area and volume. Okay? Here is what I'm going to make you memorize for the test. Are you ready? This test that you have at the end of this chapter, I will make you memorize how to find the area and perimeter or circumference of circles, rectangles, triangles, squares. What we did in 2D figures. Some of you guys know those formulas already. What I will not make you memorize is this chart right here, but you have to know how to use it because when I'm looking here, what the heck does capital P stand for? I don't know. We're going to go through that right now, okay? So let's talk about this. Let's figure out what these things mean, okay? So we have all 5 of our general shapes on here. These 2 are polyhedrons. These 3 are not polyhedrons because they're curved edges, okay? And so let's go to prisms. S stands for surface area. Do you know what surface area means?
The total,
Like the area of the surfaces, right? Like if I was taking like this cube and trying to wrap it with paper, how much paper would I need? Does that make sense? Like if I was wrapping this present, how much paper would I need? That's surface area. Versus volume is me filling it with water and how much water it would hold. Well, it wouldn't hold anything because it's a cube and it's dense, but okay? So that's the difference, surface area and volume. All right, surface area. To find the surface area, we have this guy going on here. Let's put some dimensions in here. Let's say this side is 2 or 7, this side is 2, and the height is 3. I'm just gonna throw those numbers in there. We're not gonna find the area of this, but I'm just gonna like talk about him, okay? So, surface area is capital P times H, okay? Capital P, any capital letters are gonna be explained further down here. P is the perimeter of the base. So if I had this object, how would I find the perimeter of the base? what would the perimeter of the base be?
Is that a
Adding
seven
the
or?
side.
That's a
No,
7,
more.
that's a 7.
That's a 7?
Sorry.
So 7 plus 7 plus 2 plus
7 plus 7 plus 2 plus 2, that perimeter would give me capital P. Does that make sense? So 18 would be my capital P, okay? What is H gonna be, according to this?
3.
The height, which is 3, okay? And then 2 times what's capital B stand for?
Base.
The base, which base?
Next.
There's 2 bases.
Yeah.
Like there's 2 base numbers, 7 and 2. Which one do I use?
Base.
What is capital B actually means the area of the base, alright? So I'm gonna use 7 and 2, right? What would my capital B be in this case? 14, area of the bottom.
Which one is the adding?
What?
Perimeter.
Perimeter is where you add them. Area is where you multiply. So capital B would be 7 times 2, which is 14, right? Okay, now here for volume, I just do capital B times H. Capital B is the area of the base times the height. So it'd be like 14 times 3, and that's it. Got it? Let's go over to a pyramid, okay? On a pyramid, we know what capital P stands for, right? So if this is like 3 and 3 and 3 and 3, my capital P would be 12, right? Adding all of those up. Okay, now this is the confusing part. They have an L and they have an H. What does L stand for? The slant height.
Yes.
L stands for slant height. I'm gonna go to, don't flip, but I'm gonna go to this figure right here. No, let's not. Let's go to right here, this figure. Okay, if I go over to cone, cone is also gonna have slant height, but you can see it a little bit better. The slant height is the slanted edge, that distance, but the regular height is like me driving a rod down the center of it. Does that make sense? Okay, so the slant height here, this is the slanted edge versus like the pole that goes down the center to the middle. Does that make sense? Okay, so there's a difference between the two. All right, we have slant height and we have regular height. Okay, and then we have capital B again, which is the area of the base. What's the area of this base? 9, 3 times 3, okay. All right, so this guy, cylinder, is pretty straightforward. There's nothing missing here. You have a height and you have a radius. So all you do is 2 times pi times the radius times the height plus 2 pi r squared. Woo! It's a lot of stuff. All right, volume, pi r squared h. Pretty straightforward. You just have to type it into your calculator and have it do it, okay. Cone, again, has height and slant height and the radius. So you're going to plop those numbers into your surface area or your volume formula, okay? A sphere is only going to have one dimension. It's just the radius. All of these are based upon just the radius, okay? Now, one more thing that I'm going to say before we move on and actually do something. Check out these two formulas right here. Volume of a cylinder and volume of a cone. What
Basically the same
is
except
the
for-
trend? What?
They're the same except
A cone is a third of the volume of a cylinder. If I try to like add to this cone, do you see how he would maybe be like in 3 parts?
Yeah.
Yeah. So the volume of a cone is a third of the volume of a cylinder. All right, now let's do the same thing over here. Check this one out. The volume of a pyramid is 1/3 the volume of a prism. Do you see that? You see how he would be like into thirds, right? Okay, that's on purpose. That's a thing. Okay. All right, let's go to example 3. We'll do example 3 and example 4, and then we'll stop. Okay, and I'll give you just a little bit of homework. Okay, here we go. Find the surface area and the volume of the cone. Okay, so I'm gonna start by, I'm gonna go down here, surface area, and I'm gonna write the formula for surface area of a cone. He is pi RL plus pi r squared. Pi RL plus pi r squared, okay? And then volume, I'm gonna do volume down here. Volume is